Hello friends, myself Pramod Shivgunde, HOD of Electronics and Telecommunication Engineering Department, Siddheshwar Women's Polytechnic. Today I continue the session of EJ5I of the subject Control System and PLC. In that we have seen last time closed loop and open loop control system and their classification also. Today we will see determine transfer function of given RLC network. In that so many networks, we have to find out transfer function of given any network. So hereby I have taken one simple example, RC network. RC network, there are two elements R and C. See here, input is applied at one side and output is taken across one network element. Input, that is, you may denote as VI and output is denoted as VO. The transfer function, how to find out transfer function? The transfer function is nothing but Laplace transform of output response divided by Laplace transform of input excitation. So output and input both are in time domain. When we find out Laplace of that time domain voltage, we will get the VO of S, VI of S. So we have to find out VO of S, VI of S. What is S? S means S domain, that is Laplace transform. See here, time domain, we can find out its S domain. S domain means we have to find out Laplace transform of given parameter. See here, voltage across R, that is represented in time domain VR of t is equal to R into I, but I is instantaneous changing element. So current, that is I of t, so R into I of t. This is in time domain, but we have to find out in S domain. To find out the transfer function, the transfer function is in the form of S domain. So we have to find out in S domain. VR of S is equal to R into capital I of S. Small I is represented by capital I and small s. Similarly, capacitor voltage, this is in time domain Vc of t is equal to, it is represented in 1 by C integration of current with respect to time, and its Laplace transform or is represented in S domain, that is VCS is equal to capital I of S divided by SC. This S should be small. Next one, inductor VL of T. How to find out voltage across inductor? L, that is inductor. RCL, these are the constant value. It will not change with time, so it's acting as a constant, L into di by dt. So find out the Laplace transform of that VL of t become VL of S is equal to this di by dt, d by dt becomes S constant L multiplied by this small I becomes capital I and t is replaced by S. So S into L into I of S. So these three formulas we must be remember to solve this RLC network, transfer function of this RLC network. Now we have to find out input equation and therefore output equation. Input equation, it is represented in VI of t is equal to the current flowing through this element R and C. So current into R, that is represented R into I of t. This current into C, that means the voltage drop across R across C, it is represented like this. So R into I of t plus 1 by C integration I of t dt. This is the second equation. First equation is transfer function. What we have to find out? We have to find out VO of S and VI of S. So out of this First we have to find out Vi of t in time domain. This is the second equation. So to convert it into Vi of s, take Laplace of Vi of t. Vi of t becomes Vi of s, r as it is, I of t becomes I of s. Then we know how to find out Laplace of this term, or how to represent in s domain. I of t becomes capital I of s. This integration sign, its Laplace is 1 by s and c acting as a constant. This is the c. Just simplify this equation. I of s and I of s give common, then bracket r plus 1 by sc. Again we have to simplify that. Just take denominator common and the equation becomes src plus 1 divided by sc. This I of s we have taken common. So it's a third equation. First equation, that is transfer function, what we have to find out. Second equation, that is in terms of time domain. And third equation we found in s domain. Now Vi of s we found this one. Now we have to find out Vo of s. First, Vo of t, time domain. The voltage across C is acting as the output voltage. The output voltage is becomes 1 by C integration of I of t. To find out its s domain, the Laplace of Vo of t becomes Vo of s is equal to the Laplace of this term, the Laplace of this one, I of s divided by sc. So it's a fifth equation. Just we found V of s as well as Vi of s. So third equation and fifth equation. Transfer function is equal to Vo of s divided by Vi of s. Put up the values, third equation and fifth equation. Fifth equation here and this third equation just put up here. Here I of s get cancelled. Again this term also get cancelled, sc. Lastly the output is